Hello everyone, welcome back to Pre-Algebra with Miss Betsy. Today we're going to be finishing up Chapter 4 where we have been discussing working with integers, and we're going to see how it is that we solve integer equations using multiplication and division. This is the text that I am teaching from. It is the first edition of Pre-Algebra for Christian Schools published by Bob Jones University Press. The second edition, they have totally changed around the order of things, but you can still gain some value from this lecture nonetheless. We'll be in section 4.7 beginning on page 130 in just a moment, but let's go ahead and pray. And I have a lame joke for you, and we'll spend a little bit more time on this section than we have on the preceding two lectures, just so we can make sure that everybody understands what's going on. So let's pray. Father, I thank you for who you are. I thank you that you are so much bigger than I am, and that you know the end from the beginning. And even as I was walking away from the video camera, I was thinking about how you relate to algebra and to the vocabulary that we've been studying of variables and constants. And variables have differing values depending on what numbers put in there, but Lord, you're not a variable, you are a constant. And we learned that the constant is just a number that never changes. So I thank you, Father, that you are a constant presence in our life and that you love us. And I pray this in the name of your Son, Jesus. Amen. Okay, lame joke. I really like having books at the library. It's much easier than sifting through a ton of horrible ones on the internet. Plus, you get to look at the pictures, too. Can you tell me why did the snake play with building blocks? He played with building blocks because he was a boa constructor. I thought that one was quite cute. And I particularly love the fact that our boa constructor there is purple. So, solving integer equations. And you've already had a lot of practice working with equations. Let's say that we have 4x is equal to 20, and you have x divided by 3 is equal to 6. And how was it that you determined how to solve these? And again, I'm sorry I don't have colored markers with me today. But there were two steps involved in solving a basic algebraic equation. First, you saw what has been done to the variable. And if you look on your book on page 131, it says, identify the operation that has been performed on the variable. So, what's up with the variable? Or what's up with x? Whatever the variable is, what's happened? Well, here, x has been multiplied by 4. And in my second example up here on the board, x has been divided by 3. All right? So, we've already identified what's up with x. And our book tells us again on page 131, undo the operation by performing the inverse operation on both sides of the equation. You remember that an equation is like a balanced seesaw. With the equal sign is the center balancing point. And we're going to apply the inverse to both sides. The inverse operation to both sides of the equation. What are inverse operations? Inverse operations undo one another. I use that old example over and over again. You put a jacket on, you zip it up, that's one operation. You unzip it, that's the inverse operation, and it undoes it. You're right back where you started. Addition and subtraction are inverse operations. Multiplication and division are inverse operations. We look at this first one, we say, okay, what's up with x? What's going on? It's been multiplied by 4. The inverse of multiplication is division, so we are going to divide both sides of the equation by 4. You must show your step. Co-op kids, you've got to be showing this step for me, because this is an algebraic process. And then you can cancel common factors, and you say that x is not equal to 20. X is equal to 5. If you need to show your division out here to the right, that's fine. The second example that I had was x divided by 3 is equal to 6. First, what's up with x? X has been divided by 3. We're going to take the inverse of division, which is multiplication, and we're going to now show on your paper that you are multiplying both sides of the equation by 3. And this is where I would be using a different color marker to say that my equation is still in balance. I've multiplied the left-hand side and the right-hand side of the equation by 3. This here could be written as, if it's difficult for you to see and to understand that you are multiplying by fraction, 3 over 1, and that you can cancel common factors, rewrite that whole number as a rational expression divided by 1, and then it's obvious that you can cancel numerator and denominator. You have x, 3 sixths are 18. Okay? Brief review of how you solve equations using inverse operations. Now, you're going to do exactly the same thing with multiplication and division equations that include integers, which means that you're going to have to remember your sign rules for if your answer is going to be positive or negative. So let's go ahead and do example 1 on page 131. Example 1 says solve and check negative 4n is equal to 68. And these are going to be solve and check. Now remember, you should always be checking, mentally checking your work, but anytime it specifically tells you to check, that's half of the problem. You have to show me a written check. We're going to look at this and say, what has happened to the variable? Well, it has been multiplied by not 4, but it's been multiplied by a negative 4. So we're going to divide by the very same amount that we multiplied by. Going to divide by negative 4. To keep our equation in balance, what you do to the left-hand side of the equation, you must do the exact same thing on the right, or something that has the same value. So we're going to divide this side of the equation by 4. Now you have to remember that if you divide two numbers, you have a dividend and divisor. They're the same quotient. The answer is always positive. If they're the same, their quotient is positive. Or you can simply think of this as any number divided by itself is always equal to 1. So n is equal to, now if you need to do this division out by the side, that would be perfectly fine. You have 68 divided by 4, 28, 7. So you just divide 68 by 4, not even worrying about the sign. And then you remember your rule that says that if you have a dividend and a divisor that have opposite signs, dividend and divisor have different signs or opposite signs, that quotient or that resulting answer is always going to be negative. So now, how are we going to check this? Same way that we check anything else. We rewrite our original equation, and then we substitute in the value for the variable. And here is a negative 17. And I'm going to show my multiplication like that because it's screaming obvious that I have two negative factors multiplied together. And so you say negative 4 times a negative 17, is that equal to a positive 68? And you remember your teaching from 2 sections ago that says, yeah, if I have two factors, as long as the signs are the same, it doesn't matter if they're negative or positive. That product is always going to be positive. And there you have verified. First, you've solved your problem by applying the inverse, which is division by a negative 4 to both sides of the equation, resulting with the solution that says that the value for n is a negative 17. Then you have checked that by substituting a negative 17 in for the original variable, resulting in negative 4 times negative 17. You know that the product of two negative numbers is always going to be positive, and thus you have verified and validated that your solution is correct. That's all that's involved in this. So let's go ahead and look at example 2 now. And we're going to find that one on page 131. Example 2 says, solve and check. Solve and check. N divided by a negative 3 is equal to a negative 15. What have we done with the variable here? Well, it has been divided not by a positive 3, but it has been divided by a negative 3. The inverse of division is multiplication. So we know that we're going to multiply both sides of the equation by something. We're going to multiply by a negative 3. Multiply both sides of that equation by a negative 3. Now, I very intentionally used parentheses here. I didn't use parentheses here to show you it means the same thing. Now, we have numerator and denominator that are the same. You can cancel those because they are common factors. Negative 3 divided by negative 3, as long as you have the same numerator in the numerator, the same number in the numerator as you do in the denominator, your product is always going to be equal to 1. So we now have n is equal to 45, because 3 times 15 is 45. You look at the fact that those two factors have the same sign. Doesn't matter that they're negative. What matters is that the signs are the same. So the product is a positive 45 here. Now we have to check. How are we going to do this? You're going to write it out for me, and you're going to copy down your original problem. N over a negative 3 is equal to a negative 15. We're going to substitute in the value that we have for n. So we have 45 divided by a negative 3. Is that equal to a negative 15? Well, let's remember, quotient is going to be negative if our dividend and divisor have opposite signs. Now, I said that differently than I've had before, but it means the same thing. I started with the quotient instead of starting with the division problem. If you have a dividend and a divisor that have opposite signs, their quotient will be negative. That is not going to change. Negative 15 is equal to a negative 15. That's all that's involved with this, but we have one special case that sometimes trips people up, and I'm going to teach it to you. I'm going to step you through it the way that they show you in your book. This is totally optional, this part, if you convert this to a negative 1 or not. And you'll see what I mean in just a moment. We have negative n is equal to 37, and we want to solve this. You can read this negative n equals 37, or the opposite of n is equal to 37. And what does this really actually mean? This actually means this is the same as saying this is a negative 1 times n is equal to 37. Remember, we've also said that if you don't see a number in front of your variable, you understand that it's a 1. Because we have a negative sign, it's a negative 1 in front of the variable. So if it helps you to rewrite it like this, So I'm going to put rewriting is optional. Okay? Now, what has happened here? We've multiplied n by -1. So we're going to apply the inverse operation, which is division. And we're going to divide both sides of the equation now by -1. Same number in the numerator and the denominator. Those are common factors that we cancel. We have n is equal to, well, obviously 37 divided by 1 is 37. And it's going to be a -37, because if you have a dividend and a divisor with different signs, the quotient is always negative. Let's go ahead and check by substituting in. The opposite of a -37, is that equal to a positive 37? This is the same as saying -1 times a -37. Is that equal to 37? Yes, because if you have two factors whose signs are the same, the product is always positive, regardless of if those signs are negative or positive. So let's do just a couple examples more from the skill check, and then we will be finished with the work for Chapter 4. Okay, what inverse operation are you going to use to solve these? 2, 3, and 4. -4x equals 52. 2. N over 14 is a -3. 39 is equal to -r. -5 is equal to b over a -23. And putting those signs in there might tempt you to get a little bit psyched out here. This is nothing that you haven't already done, nothing to be intimidated by. What's happened to the variable here? X has been multiplied. What's the inverse of multiplication? It's going to be division. So the operation that we'll use is division. What's happened to the variable here? It's been divided by 14. Inverse of division is multiplication. So we're going to multiply. Here, this is a -r. How about if I just make this a -x instead of a -r? What has happened here? X has been multiplied by -1, so we're going to divide. And it does not matter, remember, it doesn't matter which side of the equal sign the variable is on. What's happened here? We've divided, so we're going to multiply. This is all they wanted you to do here, but what would we be doing if we were solving? You would be dividing both sides of the equation by a -4. You would be multiplying both sides of the equation by a positive 14. Dividing both sides of the equation by a -1. Multiplying both sides of the equation by a -23. That's all that's involved in that. Now let's look at a couple of these examples. I'm just going to pick no more than 3 more examples. Let's say that we have, this is problem number 5 in the skill check, we have -3y is equal to 39. Doesn't say check, so we're not going to check. -3 times y, y has been multiplied by a -3. So we are going to divide both sides of that equation by a -3. We have a common factor that cancels of a -3. We have y is equal to 39 divided by a -3. 39 divided by 3 is 13. Your quotient, however, is going to be negative. So our solution is y is equal to negative 13 because when you have dividend and divisor that have opposite signs, your quotient, or the answer to that division problem, is always going to be negative. So now let's look at problem number 8. Well, let's not look at problem number 8 because it's going to be positive. Well, let's go ahead and do it anyway. A over 9 is equal to 51. This is number 8. What are we going to do? We look and see what operation's been performed on the variable. Here, A has been divided by 9. The inverse operation is 9. That means the inverse operation is multiplication. So that means that we are going to we're going to multiply both sides of the equation by a positive 9. Once again, our factors of 9 cancel, and we have A is equal to 5 9s are 45 and 9. A is equal to a positive 459 because we only have positive numbers in here. This is something you've known how to do for a long time. Now, let me select one final problem. Let me do problem number 6. Problem number 6 is negative 126 is equal to negative 9t. We said that it does not matter in the least which side of the equal sign that variable is on. But if it just messes with your mind and really bothers you, remember, seesaw is still in balance regardless of what side you're looking at it from the front or the back. So you may switch this around if your mind likes it better for the variable to be on the left-hand side. That's totally optional for you to rewrite this. Now, you look at the t, at the variable, and say, what's happened here? Well, t has been multiplied by a negative 3. The inverse of multiplication is division, so we are going to divide by exactly the same amount that t was multiplied by, which is a negative 9. Our equation is now out of balance because we only divided one side of that equation by a negative 9. We make sure that we divide the other side of the equation by a negative 9, and our seesaw is now back in balance. Common factors of negative 9, t is equal to, I think, 14. 126 divided by 9, 36. Yeah. Kids, in my co-op class, you have to show your steps like this. I'm teaching, you've got to know the algebraic method. If you have to do your arithmetic out to the side, go ahead and do it. Okay, we have a 14. 126 divided by 9 is 14. Now, is that going to be a positive 9? I'm sorry, a positive 14 or negative? Well, dividend and divisor here have the same sign. So the sign of the quotient is positive. Has nothing to do with the fact that there are negatives over here. What determines the sign of the quotient is if the signs of the dividend and divisor are the same, regardless of whether they're both negatives or both positives. So t in this problem has a value of 14. And that's the conclusion of our lectures for Chapter 4. Send me a text if you are having difficulty. Otherwise, I will see you in class.